Hi, in this video, I'm going to discuss topic 2.7, which is going to cover residuals. We have two learning objectives here. The first being we want to represent differences between measured and predicted responses using residual plots. And the second objective is to describe the form of association of bivariate data using residual plots. All right, so let's start with what is a residual? So here I have a scatter plot of some data that we used in a previous video. The explanatory variable is anxiety level, and the response variable is exam score. Okay, this data has a pretty moderate negative linear pattern to it. Okay, there's a negative association between the two variables. All right, so a residual is the difference between an actual response value and the predicted response value from the model. Okay. All right, so to illustrate that, let's look at this point right here. Okay. So that point represents a student whose actual exam score was 70. Okay. And then if we look at the linear model, right, which would be this point here on the line, right, the linear model predicts that a student with that anxiety level, and that anxiety was, 10, 8, 6, 4, right? That the model predicts an exam score of just under 67. Okay? And so we calculate the difference, right? And we get a residual. Okay? So the residual value would be just over 3 points. Okay? So the interpretation here would be that this particular student scored higher than what the model predicted by 3 points, right? They scored 3 points higher than what the model predicted. Okay. All right. So here's an example of a positive residual, okay? When a value outperforms the model's prediction. Okay. Let's look at the next student over to the right, okay? And so that student had an exam score of 50 points, okay? And then based on that anxiety level, we could go to the linear model and get a predicted exam score, which would be about 63 points, and then take that difference to get the residual, okay? So 50 minus 63 gives us a residual of negative 13.359. Okay. So in this case, we would say that our particular student scored 13 points below what the model predicted, okay? Or the student underperformed compared to what the model predicted. All right, so here's a formula for calculating residuals. It's y minus y hat. Okay? So the y refers to the actual response value, and y hat refers to the value that the model predicts, so the predicted response value. All right, so we can then calculate the residual for every data point in our scatter plot and then create what's called a residual plot. Now this is just another scatter plot, but instead of x versus y, we're going to graph x versus the residuals, okay? So on the y-axis, we'll have the residual values, and then on the x-axis will be the explanatory values. All right, so what a residual plot does is it removes the linear pattern in the data to reveal if there is any other patterns that remain. Okay. So if we use that logic, then a scatter plot that has a linear form to begin with, right, will have a residual plot that has no pattern, right? Since the linear pattern would be removed, there shouldn't be any other pattern left, and so it's going to look pretty random. So here's an example. Okay. So this is a scatter plot, okay, x versus y, and you can see how the points follow a linear model very nicely. And then here is the residual plot, okay? So the x-axis still goes from 0 to 10, okay, just like the original x-axis did, okay? But our vertical axis only goes from about -2 to +2, right? And that's because the distances between our points and the linear model are fairly small, right? And so now you can see that, you know, there is really no pattern here. It just looks like a random cloud of dots, right? Because we've already removed the linear pattern and there's no other pattern there in the scatter plot. Okay. Now look at this scatter plot. Okay. So the data reveal a very clear curved pattern. Okay. Yet we still fit a linear model to it. So obviously that wasn't the right thing to do, right? A line does not describe that curve pattern very well, okay? And the residual plot is just going to pronounce that even more, okay? So after we remove the linear pattern, right, we can still see the curved pattern, right? That still exists in the residual plot, okay? And then you can see like this cluster of points here, right? These would all have positive residuals. They're above the regression line. And they show up as this cluster right here. And then this cluster of points here, they all have negative residuals. They're below the regression line, and that shows up as the bottom part of the curve here. And then our last cluster of points, again, all have positive residuals, and that shows up over here in the residual plot. Okay. So since our original data was curved, right, we're still going to see that pattern in the residual plot, okay, because the residual plot will only remove linear patterns. It's not going to remove any curve patterns. And here's one final example where kind of there's an overall upward trend, but the data is clearly not linear. It's periodic, right? So it has peaks and valleys, right? It goes up and down, right? So maybe this is, you know, stock market prices or something like that. Okay. So when we create a residual plot, okay, it's going to remove the linear pattern, but it cannot remove the periodic pattern. So you're still going to see, right, those peaks and valleys, right? It's just been like transformed to be more horizontal in nature as opposed to upward in nature, okay? But the periods, the highs and lows, the peaks and valleys still exist. Okay. So kind of one of the benefits or one of the uses of a residual plot is to determine whether a linear model was good to begin with, right? So when the residual plot is very random looking, right, that is an indication that a linear model was good because there is no pattern left over, okay? When you see curves and periods in your residual plot, right, that is a sign that a linear model was not a good idea, right? That there's some other pattern going on. In this case, the pattern will be more pronounced. There's a curved pattern and there's a periodic pattern.